Hi guys, welcome back to my channel Vigyan Jyoti. So the next topic that we'll cover is charge. So for a long time we have been using this word charge, right? Like the electrons were negatively charged, photons were positive charge, neutrons were having no charge. So what exactly is this charge, okay? So first of all, we have to know that whether charge is a fundamental property or it's a derived property. So we have not expressed charged as some other physical quantity. Hence, we can say that it is a fundamental property. Okay, the fundamental property of whom? Of definitely of the subatomic particles. Because if we say a particular object is charged or is not charged, it is completely based on the number of electrons, whether they are losing or whether they are gaining. So in that way, we express whether a body is it's charged or it's not charged, or how much it is charged. So this is the way. Okay, next is what? It experiences force and presence of electrical and magnetic field. First of all, when it is already explained to you that when the electrons, they were jobless, they were not getting any kind of guidance, right? What to do, how to flow or something. But as soon as we introduce one battery, now we know in the battery we have the positive and the negative terminals, right? Okay, so what is a positive terminal? Where it is deficient in electrons. And what is the negative terminal? There's abundance of electrons. So adjacent, it creates a vacancy, that is one electron or more than one electron. They try to satiate the hunger of the positive terminal, and as a result, the electron gets a direction to flow. Now, how is this relevant here? Now, electron, we know they are in constant motion. Since they have charge, that means they definitely have electric field. Now, when these electrons are also placed in some other electric field, it moves, or it reacts. Okay. In the same way, there's magnetic field also. Okay. In the magnetic field also, it experiences, because electron, though as it revolves, it also spins. So for that reason, though this topic is not under the scope of class 10, but yes, definitely under 11 and 12. So the electrons also, they have that, because of the spinning nature also, they always have they experience a kind of, means they have you can say they show a movement, or they show a kind of change when they are placed in magnetic field. Okay, so we represent Q. Okay, we represent Q as what? As the symbol. Okay, not unit. The unit is Coulomb. Okay, that's already expressed. Now, what is this Q? Q is equal to Ne. Now, we know that first of all, these protons and these neutrons, they are located inside the nucleus of the atom, right? And they are not going to leave the nucleus of the atom. This also has been explained. Now the question comes here, that means the third subatomic particles, which is electron, that is not responsible. That means for movement, because after all, we know they only move, they leave or they join the atom, right? Okay, now Q equals to Ne, this much we have understood. Okay, first thing, so if this E is the charge on one electron, now there are many electrons that are either inflow or outflow, whatever, but it's just a single electron, doesn't control the whole universe, right? There are a number of electrons. That means the charge depends on the charge of one electron, and how many electrons are there. That means there's a product. Hence, Q equals to Ne. And what will be my unit of Q? Definitely Coulomb, because if the charge on one electron is obviously Coulomb, so definitely overall the unit will be Coulomb. Okay, this is very easy. Now we know there are two different types of charge. Two types of charge, as in not two different types of charge. Yes, positive, negative. And how do they behave? That way, I've already explained, right? The charged particles, they experience a force, or they behave in whom? They experience this one in the presence of magnetic field and electric field. Now the question comes here, what happens if we give two positive charges, if we bring two positive charges, two negative charges, or opposite charges? So first of all, we know that there are two charges, right? One is positive, which means lack of electrons, and negative, which means there is a sufficient amount of electrons are there, or abundant amount of electrons are there. Okay, now when a positive charged particle, if I'm considering a positive charged particle, every charged particle, they have their own electric field. Now, the direction of the electric lines of force is in this direction. For any positive charged particle, the electric lines of force is outward. But for the negatively charged particles, it's inward. Okay? Fine. So, for positively charged particle, it's outward. And for negatively charged particle, it is inward. Now the question comes here. So if I consider two positively charged particles. Now this charged particle says my electric lines of force is this, and this charged particle says my electric lines of force is this. So if two electric lines of force, they come, they are in the opposite direction, definitely they are going to clash. They are going to repel, right? That means they are not going to agree on the same point, or they can never come together. So as a result, they will repel. Now this is the electric lines of force which are coming, and the action of force, you can say the reaction of this force is repel. They will repel, okay? But for the unlike charges, what is happening? This positive charged particle and the negative charged particle, now there is a mutuality. What mutuality is there? Okay, I'll just explain it 1 second. Why, if I've discussed with positive, then why not with negative? Negative charged particle says it's going inward, and this negative charged particle says here also it's going inward. Now, if you see this thing, these are also running in the opposite direction. Hence, if they are running in the opposite direction, that means there will never be attraction. So in this case also we will term as that they will repel. Okay. Now what happens if they are positively charged? Okay. Now what does means positive body says? I will radiate, right? I will radiate my lines of force. Okay. Very good. And what does negative charge body say? The electric lines of force will go inside me. So there is a mutuality. Okay. That means the electric lines of force, if radiates from the positive, it will go inward in the negative charge. This is what the mutual, or you can say the comprehension that they have done towards each other. So as a result, since they are agreeing, since they have agreed something in common, hence they will attract. Okay. The lines that I've shown here and there is repulsion and attraction force direction. Okay. That means the reaction. Okay. But this is not electric lines of force. Remember this is not electric lines force. Okay. But this is electric line force I'm talking about, and this one also. Fine. So these are the two types of charges. And based on the two types of charges, they will repel or they will what? They will attract. Okay. Fine. Now we will calculate how many electrons are there in 1 coulomb. Okay. So this is also very easy. Okay. So Q equals to NE, right? Now we have to find out what is N. How much is present in 1 coulomb? So 1 coulomb, and this is what? We know E is how much? Minus 1.6 into 10 to the power minus 19 coulomb. This is what we have the charge on an electron, right? So 1.6 into 10 to the power minus 19 coulomb. Okay, coulomb gets cancelled. 10 to the power 19 will go up. Okay. And 1.6, I'll just eliminate this decimal sign. I'll put here 10. Now 1600, we can get an essence of force multiples. They are force multiples, right? So what I'll do is I'll pull here 100 and I'll keep here as 10 to the power 18. See, 19 plus 1 is how much? 20. Out of 20, I have extracted 2 zeros. Then remaining zeros how much? 18. Okay, then 16. Now 4 4s are 16 and 4 it's 25, right? Am I going okay? Yeah. So 4s are 16 and 4 25s are this one. 200. Okay, done. Now next, I'll just follow here itself. So again, I will be pulling, Again, I will be pulling another 100. So we have a 25 already and 10 to the power now 16. Why? Because again from here I have pulled out 2 zeros, so that because I have 4 in the denominator, so it will be 4 25s are okay 100. Now we'll calculate that means 25 into 25 is 625 into 10 to the power 16. Okay, now this many electrons are present. Just a second. Yeah. So this many electrons are present where? In 1 coulomb of charge. Can you imagine? There are how many electrons present? 625 electrons. 625 after that 16 zeros. This many electrons are present in 1 coulomb of charge. Now, if we want to denote it in a scientific form of notation, then we will put here as 6.25 into 10 to the power 18 electrons. I'll just put it. Okay, fine. This is the representation, and actually if you want to feel it, that is 625. After that 16 total zeros will be there. This many electrons are present in 1 coulomb. So in 1 coulomb, how many N is how much? 625 into 10 to the power 16. Fine. So if you again find the product, we'll get 1 Coulomb. Understood? So it's pretty simple. Okay. Thank you guys for watching this video. If you really find these videos informative and helpful, please do subscribe my channel, Vigyan Jyoti. Hit the like button and share it with your dear and near ones. And yes, please don't forget to comment because your feedback does matter.